Hello everyone, this is Poornima Deepthi working as an assistant professor in the Department of Electronics and Communication Engineering in MLR Institute of Technology. So this video is the part of the series Microprocessors and Microcontrollers. Today's lecture is totally about the addressing modes present in 8086 microprocessor. So the addressing modes in 8086 is very important because the data, how we are handling the data in the instructions is represented by addressing modes. So these addressing modes has been divided into, actually I have divided them into two parts. So in the first part, what we are learning is what are the addressing modes, how many types of addressing modes are there, what are the sequential control flow addressing modes, what are the control addressing modes, and I'll explain everything in detail and with each examples. So coming to what is the addressing modes. The addressing mode is nothing but how we are specifying the data in particular instruction. Whether we have specifying the data in format of immediate data or in the format of address or indirectly as we are mentioning, or which registers or which specified registers we are been using. So totally it depends upon the addressing modes. So there are two types of instructions in 8086. First one is sequential control flow instructions and second one is control transfer instructions. The difference between the sequential control flow and control transfer instruction is whenever we are executing any program, like let us consider one example, like we are performing addition between two numbers. Suppose I have been taking two 4-digit hexadecimal numbers and I was performing addition between these two numbers, and these two numbers are stored in AX and BX register respectively, and we are performing addition. So here the flow of execution of the instructions will be like this: 1, 2, 3. It will be continuous in one by one format. So this example particularly is nothing but the sequential control flow instructions. So when are coming to the control transfer instructions means whenever we are executing one instruction, if the control is not moving to the next instruction but it transfers the control to the other instructions depending upon the instruction, such type of instructions are known as control transfer instructions. Let us consider that jump to label 1. So suppose we are considering this instruction as label 1. So jump to label 1. So here what we are doing, after encountering this instruction, the control will be moved again to this particular instruction. So this is the transfer of the control from sequential, not sequential manner. It will transfer the control to the other instruction. Such type of instructions are known as control transfer instructions. There are separate addressing modes to represent sequential control flow instructions and control transfer instructions. Here in this particular video, I'll be discussing what are the sequential control flow instructions addressing modes. Now coming to the addressing modes, there are in sequential control transfer instructions, there are 8 addressing modes. First, immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, indexed addressing mode, register relative indexing addressing mode, based index addressing mode, relative based indexed addressing mode. These 8 addressing modes will comes under the addressing modes for sequential control transfer instructions, whereas in control transfer instructions it has been divided into two. First one is inter-segment and intra-segment. Again, inter-segment we are having inter-segment direct addressing mode, inter-segment indirect addressing mode, as well as in intra-segment also intra-segment direct addressing mode and intra-segment indirect addressing mode. So in this video I have been explaining only about the sequential control transfer addressing modes. The first one is immediate addressing mode. Here in this immediate addressing mode, the data which we will be representing will always be in the format of raw data or immediate data. That data might be of 8-bit or it might be of 16 bits. Let us consider one example. So let us consider one example that this is one example. Here you can directly see that I've been moving 1, 2, 3, 4 data into AX register. So in 8086 we have been using 4 general purpose registers AX, BX, CX and DX to perform general regular operations. Here I was moving the immediate data 1, 2, 3, 4 is the immediate 16-bit data. I've been moving it into the AX register. So directly we can immediately transfer the raw data to any one of the registers. But here the thing is we cannot write like this, because you can take the source part will be always be the immediate data. If in the case of immediate addressing mode, this data will be of 8-bit or 16-bit, but you shouldn't take the destination operand as immediate data. Such type of instructions will not be executable in 8086. So the instructions is, you can either take like this, we can take like, so here 2, 3 immediate data is moving to the BL register. BL register is a lower byte of BX register which will be having only 8 bits of data. You can we can write the direct data of 8 bits or 16 bits in this addressing mode. So coming to the next addressing mode, it is direct addressing mode. Here the data which we will be discussing will always be in addresses. Directly we can directly mention the address in that particular instruction. Let us consider one example like in this particular example, I've been moving the data present in the location of 1, 2, 3, 4. Let us consider this is the memory, and in this particular memory 1, 2, 3, 4, that should be of 8-bit data and the parallel 8-bit data. So here I was mentioning it is a register AX which is of 16-bit data. So the address present in this particular address location will be moved to the AX register. Here we are mentioning address directly. So it is nothing but the direct addressing mode. Here the data will always resides in the memory locations. You can also write like this. Yes, you can write like this. Here what the instruction is specifying, the data which is present in AX will be moved into the locations of 1, 2, 3, 4. So here to in this particular addressing mode, you can calculate the effective address or physical address by taking this 1, 2, 3, 4 as offset address. So offset address, as you all know that to calculate the physical address, it is necessary that we need to have the segment register multiplied with 10H and it should be added with the offset value. So in this particular addressing mode, the offset value will be the value which we are mentioning in the square brackets. It just represents the memory location, address of that particular memory location. So coming to the next addressing mode, it is a register addressing mode. So in this particular type of addressing mode, both the source and destination operand will be of the registers. Except IP registers, you can use any register in this addressing mode. Let us consider one example by taking. So here in this particular example, what we are saying is the data from BX will be copied to the AX register. It is of 16-bit data, or you can use 8-bit data also. So the 8-bit data which is present in the BL register will be moved to the AL register. Actually, it will be copied to the AL registers. So this is the two destination and source operand should always be the registers. And except instruction pointer, you can use the remaining all registers present in 8086 in this particular addressing mode. So coming to the next addressing mode, it is the register indirect addressing mode. As the name itself, it specifies that we are mentioning the registers but not in direct method. we are mentioning it is in the indirect method. Like one of the example will be move AX comma BX. Here what we are representing, the data present in AX. Okay, sorry. The data present in BX will be the address. The data which is present in BX will hold the address. Suppose the data which is present in BX is 5000. Now what we are indirectly mentioning, the data which is present in this particular address location will be copied to the AX register. Here we are indirectly mentioning the data. The data resides in BX will be the address. So in that particular address, data will be resides. So we need to fetch the data from that address which is present in the BX register. It is the indirect method, indirect way that we are mentioning the data. So in such case of addressing modes, the physical address will always be calculated by considering the data present in BX is of offset address. So whatever the data present in the BX will be taken as the address. So that address will be used as the offset address to calculate the effective address or physical address. So coming to the next addressing mode, it is indexed addressing mode. In this particular addressing mode, the offset of the operand will be always stored in index registers. So we are having two index registers, SI and DI, source index and destination index. And most of the cases in this addressing mode, the data will be always segment will be always the data segment. If we are using string instructions at that particular of time, we can take it as DS and ES, data segment or extra segment. So for SI it will be the data segment, for DI it will be the extra segment. Like if we want to calculate the physical address, then the segment register is data segment, the offset register will be the SI. If the segment register is extra segment, it would be the DI for only string instructions. Apart from that, if we are using directly normally without string instructions, then we can defaultly take it as the data segment. So examples of indexed registers will be like move AX, any one of the index registers, SA. Here what we are mentioning? Here we are mentioning the indirect way, but the thing is the address should be present in the SI register. Whatever the address present in the SI register will be considered as the offset value to calculate the physical address or effective address. Now coming to the next addressing mode, it would be the register relative addressing mode. Whenever you are seeing the relative term in the addressing modes, it can easily say that it is the displacement, either 8-bit displacement or it can be the 16-bit displacement. In this particular addressing mode, the register relative addressing mode, the data available in the effective address are formed by adding the displacement, either 8-bit or 16-bit displacement, with the content of the registers, base registers BX or BP, and the index registers SI and DI. Let us consider one example, like if move AX, 18H BX. In this particular address, in this particular instruction, how we will calculate the physical address? For this particular instruction, how we will calculate the physical address means, it is always default that you can take a data segment or extra segment. For extra segment, it would be the string instructions, but this is a normal instruction that I was considering it as the data segment. So in this particular instruction, the data segment will be taken as the segment register and multiplied with 10H. But what will be the offset value? In this particular instruction, the offset value is the displacement will be added with the address which is present in the BX register. So this is how we will calculate the offset value, and this offset value will be added to the data segment to find the physical address or effective address. Okay. Coming to the next addressing mode, it is the based indexed addressing mode. In this particular addressing mode, the data effective address can be calculated by adding the data present in the address present in the base registers along with the address present in the index registers. The base registers either BX or BP, and the segment registers either SI or DI. Let us consider one example, like if we are writing one example, move AX comma BX DI. So this is one of the example for based indexed addressing mode. Here we are representing the base register along with the index register. So how to calculate the physical address? So for physical address, it is normal that we will take segment register as the data segment register. Along with segment register, the offset value will be calculated by taking the addresses which is present in BX along with DX. So we need to add these two addresses to get the offset value, and the segment value will be enclosed by the DS register, data segment register. So coming to the next addressing mode, it is the relative based indexed addressing mode. As I already told you, whenever we are seeing the relative term in the instruction addressing mode, you can say that it is a displacement, either 8-bit displacement or it will be the 16-bit displacement. So here one of the example will be move AX comma, if we are mentioning displacement like this. So this is the 16-bit displacement. So base register I will be taking BP and index register I have been taking SA. So how to calculate the offset address? So the offset address will be available by taking this displacement, adding this displacement to the data present in base register and data present in index register. So this is how we will calculate the offset address of this particular instruction. So as you all know that for this thing, the segment register would be the DS. Apart from string instructions, we will always consider the segment register as the data segment. So here the physical address will be the data segment multiplied with 10H, and the offset address will be this displacement plus the data present in the base register along with the data present with the index registers. So until now I have been discussing what are the addressing modes and how many types of addressing modes are there according to the instruction format, and how this data control sequential instruction addressing modes will be there and each addressing mode. Thank you.